So we just finished a fantastic few segments, and now it's time for our math challenge. That's right. So let's go ahead and dive into it. And this one is Christmas themed. We've got Ladderman's Christmas. So I'm excited to share this challenge with you. Let's take a look at some of the different elements that are in this challenge. So of course we have Ladderman, and he's all ready for Christmas. He's got his Christmas hat on, he's got his light bulbs, and he's about to go up and put his light bulbs on his house. And we want to know, how high is Ladderman gonna be off the ground when he climbs up this ladder to the very top? Okay, so we want to know how high he's going to be off the ground, because we're concerned about Ladderman, right? We want to know for safety reasons, right? What is the most likely injury that could occur to Ladderman based off how high he is off the ground? Is this a safe height? What's the worst case injury? And so we want to know how high Ladderman is off the ground, because we want to have a nice, safe Christmas. And so we're given a little bit of information about this ladder, the angle of the ladder, and we're given some extra little bits. But this is really all we need to figure out what the height is for Ladderman here. So first things first, we see our ladder here, okay? And there are 8 rungs on this ladder. 8 rungs, we can count them. 1, 2, 3, 4, 5, 6, 7, 8, okay? And the distance between each rung is 0.75 feet. Okay, so that is the distance between each of the rungs on the ladder. All right. Now, next we know that the angle of the ladder is 60 degrees. Okay, so the angle of our ladder here is 60 degrees. Okay, and we're also given a little bit of extra information down here at the bottom, okay? So you're probably gonna need a calculator for this problem. And we're also given one of these known as a special triangle, okay, down here, the special triangle. You might have heard about this, you might not have, and that's okay. But the special triangle is a special kind of triangle because we know all the sides, we know all the angles inside this triangle, and we see this triangle quite a lot. Okay, so it's a useful one to have. So up here at the top, we've got 60 degrees. And notice that these two adjacent sides are 1 and 2. And down here at the bottom, we've got 30 degrees. And notice that the adjacent sides again are square root 3 and 2. So this special triangle is going to be important for solving this problem. Okay, so that's why I've given it to you there. Now, lastly, we want to know how high is Ladderman at the top of the ladder in meters, okay? So we need the conversion from feet to meters. So 1 foot is approximately equal to 0.305 meters, okay? All right. Denote that little m. So 1 foot is approximately 0.305 meters. So hopefully with this conversion, the special triangle, and the information in our problem, we have enough to solve this problem and figure out how high off the ground Ladderman is going to be. And I think we're going to realize, you might realize, that Ladderman is not very big. So yeah, he's living in a gingerbread house, okay? Yeah, so just for reference. But there you go, that is your math challenge. Don't go anywhere, because up next we've got some questions regarding the segments. We've got our maker highlights and engineering tribute, so stay tuned. this is our Ladderman Christmas solution. So I hope you're ready. I hope you're excited. Let's go ahead and jump into it. So first things first, if you remember when we left off, we needed to know how high Ladderman was off the ground. Okay, and we were given a few things. We were given the distance between the rungs. Okay, and we know that there's 8 rungs. We were given the angle that the ladder is up at, leaning against the house. We were given a conversion from feet to meters, and we were given a special triangle. So let's go ahead and start working our way towards the solution to this problem. So first things first, pretty easy. If there's 8 rungs here, we can figure out how long the ladder should be, right? So if we see there's the distance between each rung is 0.75. So if we count, okay, if we count, we've got, if we look at the segments between each rung, you can see that there is actually 1, 2, 3, 4, 5, 6, 7, okay? So even though there's 8 rungs, okay, there's actually 7 segments, okay? So the length of the ladder is actually going to be 0.75 multiplied by 7, okay? So I'm going to denote this as D. And we're going to say D is equal to 0.75 times 7, okay? And it says here we need a calculator, and I'm going to use my calculator here. 7 times 0.75. We end up with 5.25 feet. Okay. All right, so now we have this total length, all right? D. And we need to figure out what the height is. And we were given this special triangle, and that's going to be very important now, because you'll notice if we rotate it like this, we get the same angle down here at the bottom. Okay? So I know, let's go ahead and let's label these. So instead of D, let's figure out where I can draw this. I'm going to draw this right here. Get rid of our nice house for a minute. Okay. So I'm going to draw this as D, H, and A. Okay? And what we're going to do is I'm going to mark this as 60. This is 30. And 45, or 90, sorry. And by looking at the special triangle, these proportions are going to be constant, okay? So the proportion between D here, D, A, and H, okay? We can use these proportions to figure out the relationships between the sides. Okay, so for example, D is always 2 times A, all right? So from our special triangle, we know that D is equal to 2A. We also know that H is equal to, let's see, well, we've got root 3. So let's do it this way. H over D is equal to root 3 over 2. Okay? And then we can just bring D up over here. So H is equal to root 3 over 2. And so we already have D. We need to figure out what H is. So that is root 3 over 2 multiplied by 5.25. So let's do that. So root 3. So we're going to do 3 square root divided by 2. And then times 5.25. And we get the height. So H here is actually 4.5466 feet. okay? And I don't care really about these last two, so we'll just simplify to 4.5. These last three. So we'll just say it's about, we'll do that, okay? So to 2 decimal places, we'll say it's approximately 4.55. And now, we're not quite done because that's feet. We need to convert to meters. So we're gonna multiply by 0.305. 0.305, and we end up with h is equal to 1.3867 meters. And again, I don't care about, I only want the last 2 digits, so we'll just say that it's about 1.39, okay, meters. But there we go. We have our solution, okay? And we notice that the gingerbread man, or ladder man, is not very tall, right? He's actually, this height that he's climbing up, that super high height, it's only maybe about here on me. So he's not, he's maybe, if we look at this diagram, maybe he's about this tall. Maybe you can tell me, because it looks like ladder man is about halfway. So maybe bonus question, you can tell me how tall is Ladderman if he's about half of h, okay? How tall is Ladderman? But that is your solution to the problem. I hope that you enjoyed. Again, h is equal to 1.39 meters, and I hope you have a fantastic day.